Welcome to this M1 video on resultant moments. So, like I mentioned in the previous video, when you have several forces acting on a body, now these will be coplanar forces, which are forces that act in the same plane. Okay, and when you have several forces that acting on a body, you can basically add all the forces up. You pick a direction as your positive direction, either clockwise or anti-clockwise, and then positive values for the ones in your positive direction, negative values for the ones in your negative direction, sum them all up and find out your resultant force, the force that you're left with. Okay, and then that then is called the resultant momentum, which is effectively what's happening to body. So as we kind of mentioned with the previous ones, if I have like a rod like shown here and I have this force here, we'll call it F newtons. Okay, acting at P, and that's going to give me a distance of X. Now that is going to give me a moment in the clockwise direction, isn't it? Because it's going to spin this way about P. So this would have a moment. So the moment of F is going to be F times X, isn't it? And that's going to be clockwise. Then if I have a force, let's call it P newtons, and this is a distance of Y meters from P. Oh, let's not call it P newtons because there's two P's there. Let's just call it G newtons. So this force will act anti-clockwise. So the moment of G is going to be G times Y, and it's going to be anti-clockwise. Okay, now usually you find out these actual values and then it's pretty obvious which direction is going to be the positive direction because you can see. But if you can't see, you'd pick a direction. So, choosing clockwise as positive. Okay, then the resultant moment will be Fx minus Gy. Okay, adding them up. So effectively what I'm doing is I am really adding them, but the Gy is in the negative direction. Okay, because I've picked clockwise as my positive, and whatever value this is, it'll leave me a resultant value clockwise. And if that value is negative, then I can turn it into a positive value by then changing the direction. So if this, for example, came out and give me, it's minus 10 Newton meters. So minus 10 Newton meters clockwise will be the same as 10 Newton meters anti-clockwise. Okay, so that's kind of what we're going to be looking at in today's video. This is really now just finding the resultant moments, and it's building up towards the type of questions that you'll see in your actual exam. Okay, so we're just building towards that. Now let's look at just the one example today. So here we have a diagram showing a set of forces acting upon a light rod. Calculate the resultant moment of P. Okay, so we want the moment of each force individually. So let's do the moment of the 10 Newton force. So that is going to be 10 times, now it's 2, 4, 6 meters from P. So it's 10 times 6, so it's 60 Newton meters. And the direction it's going is going to go around this direction, which is clockwise. Okay, now let's do the moment of the 3 Newton force. And that's this one, and it's 2, 4 meters from P. So that's 3 times 4, so that's going to be 12 Newton meters. And this is going to go around this way, so anti-clockwise. Now let's look at the moment of the 5 Newton force. So it's going to be 5 times 2. So it's 10 Newton meters, and again it's anti-clockwise. And then finally, let's look at the moment of the 8 Newton force. And that's going to be 8 times by 2, because it's 8 and it's 2 meters from P. And that's going to be 16 Newton meters. And it's going this way, so it's going anti-clockwise. So I can see these 3 anti-clockwise forces. Okay, but are they bigger than the clockwise one? Just having a little scan through them, 16 and 12 is 28, plus 10 is 38. It's not as big as the clockwise one. So I can see that, so I will say, you know, choosing clockwise as positive. Okay, so then the resultant moment is going to be 60 plus minus 12 plus minus 10 plus minus 16. So that's what I'm doing, I'm summing them, but it's just 16 minus 12 minus 10 minus 16. And that leaves me with 22 Newton meters clockwise. Okay, so, you know, at the very end, I can say, therefore, the resultant moment is 22 Newton meters clockwise. I don't have to say that, I can obviously just leave the clockwise in here, as I've already written resultant moment there. Okay, now that's all there is to it for these. Okay, obviously you could have ones with angles in them, but moving forward, we're going to see, you know, questions with less of angles, more of, you know, forces at right angles and things, but the questions getting more and more complicated. Okay, where, you know, we'll start looking at centre of masses and things tilting. So moving forward, a lot of our problems are going to have forces, various forces acting at right angles. Okay, so that's kind of all there is to it in this video. I'm going to put up some questions in a moment, but just before I do that, don't forget, if you found it useful so far, hit that like button. If you're yet to subscribe, please consider hitting that subscribe button now. And if you're willing and able to help me out financially, then hit the join button. Otherwise, let's look at the questions. So 3 straightforward questions today. Pause the video now to have a go. Okay, welcome back. Let's have a look at the solutions. So in this one, we've got P over here. 12 newtons is 1 meter away from it, and 5 newtons is 4 meters away from it. So let's first find the moment of the 12 Newton force, and that's going to be 12 times 1, so it's 12 Newton meters, and it's taking it this way round, so it's going to be anti-clockwise. Now let's look at the moment of the 5 Newton force, and that's going to be 5 times 4, which is going to be 20 Newton meters, and this is taking it round clockwise. Okay, and then let's look at the resultant moment. Now I'm going to take clockwise as positive, okay, and in this one I'm just going to state the values. So 20 take away 12 is 8 Newton meters clockwise. Okay, so I've taken clockwise as positive. I haven't said it here, but that is what I am doing, and that would be, you know, more than acceptable in the exam. Now let's have a look at number 2. Similar question, but with a few more forces. So I'm going to start with this 4 Newton force. So the moment of the 4 newtons, so that's 4 times 1, 2.5, so 2.5. And that's 10 Newton meters, and it's going this direction, so it's going anti-clockwise. Now let's look at the moments of the 5 Newton force. So that's 5 times 1.5. So it's 7.5 Newton meters. And this is going this way around, which is clockwise. Now, moment of the 12 Newton force. So it's 12 times, and this is now half a meter. So 6 Newton meters, and it's going round anti-clockwise. And then finally, my 8 Newton force. And that is 8 times 0.5, which is 4 Newton meters, and again it's anti-clockwise. With a quick glance, I can see anti-clockwise is going to be my direction. So 10 minus 7.5 plus 6 plus 4, and that's going to give me 12.5 Newton meters anti-clockwise. Okay, so there is the resultant moment of question 2. Hopefully you got this one out. Now let's look at number 3. Okay, number 3, we told the resultant moment. So let's find the moments of the individual forces. So start with the 6 Newton force. So that is 6 times, now 2x plus 3x is 5x, plus x is 6x. So 6 times 6x, or 36x Newton meters. And this is going to go in this direction, so clockwise. Okay, now the moment of the 10 Newton force, that's going to be 10 times, now the distance here is 4x, so it's going to be 40x, and this is going to go anti-clockwise. And then finally, the moment of the 12 Newton force, so it's 12 times x, so this is 12x, and this direction is going to be clockwise. Now, the resultant force is equal to 12.8 Newton meters, and this is clockwise. So that means 36x minus 40x, negative for the anti-clockwise ones, plus 12x for the clockwise ones equals 12.8. So 36 plus 12 is 48, minus 40 is 8, so 8x equals 12.8. So 12.8 divided by 8 gives me 1.6. So x equals 1.6 meters. And that is how you do question 3. So that's the end of this video, a nice short video. Stay tuned for the next video, which is when we start looking at these resultant forces, but the resultant force will be 0 in the next video because we're looking at what happens when they're in equilibrium. Okay, so stay tuned, click the video at the end of this one to go ahead and watch that video.